Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. You also have a collection of URLs here with resources for studying for actuarial exams that I have created. Here's the problem for today. The current price of a stock is 200 and the continuously compounded risk-free interest rate is 4%. A dividend will be paid every quarter for the next 3 years, with the first dividend occurring 3 months from now. The amount of the first dividend is 1.50, but each subsequent dividend will be 1% higher than the one previously paid. Calculate the fair price of a 3-year forward contract on this stock. The forward price is the accumulated value of the current prepaid forward, so ex-dividend, without the dividend's price of the underlying. We can calculate the forward price as the future value of the current stock price minus the future value of each of the 12 dividends, with the time of the valuation being 3 years from now. So the forward price is 200 accumulated at over 3 years at continuously compounded 4%, minus a dividend of 1.50 increased by 1%, then again by 1%, and so on, until it's increased at the end of 3 years, and it's 11th increase because there are 12 quarters in 3 years, but the first dividend is not increased, so there are 11 increases. Now, to evaluate the second expression, we use the formula for a partial sum of a geometric series. So we write this as e to the 0.11 times 1 plus 1.01 to the first times e to the minus 0.01 to the first, and then 1.01 squared times e to the minus 0.01 squared, and so on. So we see it's the same expression to the powers from from 0 power to the 11th power, and of course that is equal to 1 minus, it's like if you have 1 plus q squared and so on up to q to the n minus 1, that's equal to 1 minus q to the n over 1 minus q. In this case, 1 minus 1.01 times e to the minus 0.01 to the 12th divided by 1 minus 1.01 times e to the negative 0.01. And of course we factored out e to the 0.11 to make sure that the rest looked like that partial sum of a geometric series. So we conclude that the forward price is 200 times e to the 0.04 times 3 minus 1.50 times e to the 0.11 times 1 minus 1.01 times e to the minus 0.01 to the 12 divided by 1 minus 1.01 times e to the minus 0.01. And that is approximately 205.41. That's answer B, and that's the end of the solution. Please remember that this is copyrighted work. The problem itself belongs to a Society of Actuaries, is reproduced with permission, and the solution is mine. Good luck in your studies and good luck on the test.